Hello and welcome everyone, and thank you for joining our second webinar in our OpenEdge TechTalk series. Last time around, I've talked around third-party identity providers and OAuth 2, but today we will be focusing on web handlers. But before I get started, I'd like to take you through some housekeeping rules. If you can't hear us, try connecting to computer audio instead of your phone audio. If you have any questions during this webinar, please submit them in the questions panel on the right-hand side of your screen. If you're wondering, we will be recording this session, and this session will be made available to you as soon as possible. As mentioned earlier, I will be talking you through OpenEdge web handlers today and how they can help you in handling REST requests and therefore building your own API. My name is Ruben Dreugen and I work as a solution engineer for Progress for over 5 years now from our Rotterdam office. So let's have a quick look at the agenda for today. Quick as in, we only have 30 minutes. First, a quick introduction of what web handlers are and since when they have been available in the OpenEdge product. Then I'll tell you what you can actually achieve using them and where you should consider using them. After that, I'd like to demo a bit of that functionality, and lastly, we'll refer you to examples and documentation references to get started yourself. As mentioned before, this session will be recorded and slides, examples and document references will be shared with you in a follow-up email. So what are web handlers? If we take a quick look at the documentation, we'll see that the definition is a web handler is a custom ABL class that inherits the OpenEdge.web.webhandler class and contains methods that enable you to handle REST requests. What this boils down to is that you can handle any incoming HTTP request using any of the available HTTP verbs like get, put, options, etc. and serve up a custom HTTP response to that request. So, in the basis, you use web handlers to create your own service interface or API, written completely in ABL. And as service interfaces provide the transport layer between requests and underlying business services. They should be able to route requests, come up with responses to those requests, and perform error handling. Obviously, they need to provide means of authentication and authorization as well. A service interface is basically a way of translating input-output formats to and from a domain model. And while JSON might be the de facto standard for REST APIs, but there is nothing that prevents you from using, in example, text or XML as input and output formats. Message of today basically is you can do whatever you want, whatever a third party might require that wants to communicate with your API. And just to be clear, service interfaces are not business domain services or business logic. It's the part that actually communicates and sends through input and output to those business services. So if you see an example today where business logic is used within the web handler, it's purely for demo purposes. So, web handlers have been available since OpenEdge 11.6 onwards and can only be used in combination with the PASOE, or Progress Application Server for OpenEdge, that we released in 11.5 onwards. What you effectively do when working with web handlers is mapping or associating an OOABL web handler class with URI patterns. It's extremely flexible as you'll have total control of the incoming HTTP request and outgoing HTTP response and the URL. And all of that is written in ABL. How cool is that? We do offer some web handlers out of the box, like the default handler, the compatibility handler for classic web speed applications, and the data object handler. You can either use one of those, extend or replace to them, and or roll your own from scratch to get exactly the behavior you need. So what does a web handler need to do? There's some tasks, like routing. So it's up for the web handler to decide what program and function should be run. Next to that, there's obviously the parameter mapping. So we want to convert anything coming from the HTTP request into ABL and back. As mentioned earlier, we have some web handlers out of the box, which are listed here, with the one exception called the data object handler, which is out of scope for this session, but basically it's a general purpose web handler with a JSON configuration file. It allows you to map custom HTTP responses, response codes, status codes, and endpoints by using a JSON format. The OpenEdge.web and OpenEdge.net packages are obviously available in the OpenEdge.net.pl, which resides in your DLC TTY netlib directory. There's a full API reference document online, which was initially created for 11.6, but there's also an 11.7 version. The link is listed. Okay, so let me show you a few examples of those web handlers created from scratch. As you can see, there's always the handle not allowed method and the handle not implemented methods, which are already there, and there's a handle get. I adjusted this handle get method only slightly. As you can see, what I added in here is I have an integer variable and I assign a path parameter to it. So let's take a step back and let's have a look at those path parameters. How do these work? So let's have a look at our project. I can create a new web handler by choosing new and web handler. This allows me to create one. Once I created one, you'll see that it will end up in the webinf OpenEdge folder within my PESOE content folder. Next, I can create a service and assign the web handler to that service, and I can do my URL mapping. As you can see here, for this service, I am using the demo web handler, and I have two resource URIs defined. So one is just a plain text /demo endpoint, but there's always also a /demo /number, and the number in this case is a parameter, a path parameter that I can use later on in the code. In the default web handler that gets created, we're just outputting a very simple string back to the response body. As you can see, we're using the web response writer, and we're using that oResponse object with an entity, which is a single string that we output. And I also added my new variable and put it into the body as well. So how can we test this? You can very easily test all of your endpoints using a program like Postman. So let's have a look at that endpoint that I just described. If I send a GET message to that endpoint, you will see is that I actually get the string and an integer value of 0. If I now add the path parameter, which should result in getting a path parameter number, then we should see is that the integer value actually gets updated to being 2, and it gets taken back in the response as well. So that's a quick example. You can find the URI definitions that you created in the OpenEdge.properties file within your instance that you deploy to of the PESOE. There are some rules with regards to how those web handlers there are some rules how and which handler is used at what time. So if you look at the build-up of the OpenEdge.properties files, you see a handler, a number for that handler, the web handler class name, and the relative URI that it refers to. It is always relative to /web, which is the transport path for PESOE. It must always have a leading /, and you can either enter text like we had demo in the example, or tokens like we had number in the example. These handlers are always matched in numeric order, so that's why I've put demo/number on top of /demo instead of vice versa, because then it will always be matched first with /demo. Handlers can and may be reused for differing paths. Each web app also has a default for no match found. Another quick example of what this looks like. So in this case, you can easily see that if a client comes up with a HTTP request, it will route them to the according handlers. If the URI is not defined, the URI pattern is not defined, it will resort to the default web handler. Okay, so let's have another look. I created another TechTalk handler, web handler as well. And as you can see, that is doing a little bit more when I do a GET. So another example of how to use, for example, the incoming request that a client sends to you is to be able to output different type of formats to the response. So let's say I have an API that retrieves all of the customers, but I want to leave it up to the client whether he will get an XML response or a JSON response. You can define that quite easily like this. So this is yet another thing that you can do. So with the incoming request, which is the web request, I can actually say I want to get the header, and I want to get the header which is named accept from the client. And if that header is actually application JSON, then I'm going to write a JSON. If the request header, the accept header by the client sent is application XML, I will write the content to XML. And obviously, I will write that same longvar to the body of the response. So let's see how that works. So I've got a client here that sends along the header application JSON and sends this to the endpoint. And obviously this needs to be a GET. As you can see, whenever you do a post, if that is not defined, it will return an error. If we now perform a GET, we can see is that we actually get all of the customers from the Sports 2020 database, and it's outputted in a JSON format. If I would change that and say, so we're not getting application JSON. What if we change that to, say, application/XML? Perform the same GET, all of our results get outputted in XML format. So instead of having to work with different endpoints for different outputs in your API, you can basically use the same endpoint and based on the client's input, either output to XML or JSON. Last example I want to show you is a slightly more complex web handler. So let's have a look at the URI definitions. As you can see, it's a very flexible one. It uses a generic service web handler and it has a lot of parameters in the URIs, so I can make it as flexible as I want. So what is the advantage of doing this? So if you follow the JSDO method, it's very prescriptive. It gets you a lot of stuff out of the box, but it does not allow you to change anything to the format of how things are exported, for example, but also not to the way the REST API is actually built up. So if you want to do it a little bit different, then for example, you could ask yourself, don't I want an endpoint perhaps to show people the metadata of my entities that I'm exposing? So what fields are actually available in that API? So if I send a GET request to the meta endpoint, you'll see is that I can actually see all of the fields available in that entity. But another example is that I can actually build up a URI that shows me not just all of the customers or a single customer, but maybe even a customer with all its orders. So if I do that, you can see is that it actually now comes back with a customer, orders, and all of his orders. So what if I call an endpoint that does not exist? Let's say trains. Trains do not exist in the Sports 2000 database. I'll go ahead, go send, and as you can see, there's suddenly this message. So I do get a 400, it's a bad request, does not exist, the endpoint, but I get a custom error, which is the following entities or combination of these entities do not exist for this API, and the entities.trains. So you can build up your own custom error messages. If we look at the code, except for the fact is that you're able to create all sorts of filters, customized sorting criteria. You can translate that all to whatever query your backend needs to get the right data. As you can see, you can easily build up your custom error messages as well. Giving a status code, giving JSON objects, or it could be text objects as well, just text strings. And as you can see, there are multiple things that I can do. So if, for example, I pass in a filter using a field that does not exist in the defined entity, then I will actually get another error as well. These are some of the things, the very powerful things you can do by using web handlers instead of one of the other prescriptive methods like the REST annotated method or the JSDO methods. Okay, so that brings me to the end of my presentation. If there are any questions, I want to ask you to please send them to my email address. That's rdroge@progress.com. This slide mentions some of the documentation references, but also has some links to samples that you can use to have some starting point to see for yourself what are the possibilities of using web handlers in OpenEdge. I would always also like to reach out to you to please join and register our Progress Talks OpenEdge 12.2 live call the 8th of April 2020 following the release of OpenEdge 12.2. And obviously, I hope to see you next session, the 14th of May, about containers and logging, the next session of this OpenEdge Tech Talks. Mentioned before, if you have any questions or suggestions, please send them to me by mail. Thank you very much for attending and hope to see you next time.